Hello everyone, in this video we are going to discuss about the relationship between the Cp and Cv. Here the letter C represents the specific heat capacity, the subscript P represents pressure, here the subscript V represents the volume. So it should be read as specific heat capacity at a constant pressure, Cv represents the specific heat capacity at constant volume. To derive the relationship between these two, first you have to know the basic enthalpy formula which relates the enthalpy and the internal energy. Enthalpy H is equal to U plus PV. This is equation 1. H is equal to U plus PV. Here the each term represents H enthalpy, U internal energy, P pressure and V volume. Sometimes the internal energy U takes the symbol of capital E. Then you know the ideal gas equation, that is PV is equal to nRT. Now substitute the value of PV in equation 1. So the above equation 1 will be modified as H is equal to U remains same plus instead of PV we substituted nRT. So nRT. Now you have to differentiate this equation with respect to temperature. So dou H divided by dou T is equal to dou U divided by dou T plus you no need to differentiate the constant term. Here the letter N and R is a constant value, so no need to differentiate that. So NR remains constant, then differentiating this T, dou T divided by dou T, right? This dou T and dou T gets cancelled. So this equation becomes dou H divided by dou T is equal to dou U divided by dou T plus NR. As you know, the value of dou H divided by dou T at a constant P is the value of Cp. Then dou U divided by dou T at a constant V is Cv. Now substitute these two values in these equation. We get, instead of this dou H divided by dou T, it will become Cp. Instead of this dou U divided by dou T, you will substitute Cv plus Nr. Now consider for 1 mole of ideal gas, substitute N is equal to 1. This equation becomes Cp is equal to Cv plus 1 into R becomes R. So Cp is equal to Cv plus R. For Cv, just move this plus R to the opposite side. Now the value of Cv becomes the difference between the Cp minus R. Then rearranging this equation, from first you can attain the third equation. From first equation you can attain the third equation by Cp. Instead of this plus Cv, will move to the left hand side by minus Cv is equal to R. So Cp minus Cv is equal to R. So this is a relation between the Cp and Cv in terms of ideal gas equation. So which implies that the difference between the specific heat capacity at constant pressure and specific heat capacity at constant volume, which is always equal to the universal gas constant R. Here the one more thing is the Cp is always greater than Cv. It's very important. Cp is always greater than Cv. Thank you.